Welcome, ladies and gentlemen, to the end of Unit 9 of Geometry. Kind of this whole thing has been about different shapes, different figures, and kind of how they work, figuring out surface area volume. So this last little piece, we start to compare things to each other and figure out kind of what kind of relationships exist there. So you need to be able to identify congruent similar solids and take a look at properties of similar. So take a look, similar solids. Similar in geometry, remember, has a very, very distinct meaning, okay? Similar means congruent angles and then proportional sides, okay? And that doesn't change a whole lot in when you talk about figures. It's kind of that same idea, is that two solids are similar if they have the same shape. So that should be shape, and the blank of their corresponding linear measures are in proportion. Okay, so the measure, let's do this. The measure of their corresponding linear measures are proportional or in proportion. So that's kind of how the rules of the of similar shapes go. They're similar. They have the same shape, so you got a cone here and a cone here. Okay, you're not comparing a cone to a pyramid. Okay, there's no way that's similar. That doesn't work. And then the measure of their sides are in proportion. Congruent solids are exactly what it sounds like. Okay, everything is congruent. Okay, congruent sides. Corresponding sides are congruent, corresponding heights are congruent, basically corresponding slant heights are congruent. Kind of everything is congruent, and here I just kind of say just all everything. Basically, the both shapes are entirely the same. Okay, so every measure is the same. So state whether these similar, congruent, or neither. If they're similar, state the scale factor. So if I take a look, okay, 4 and 6 are not equal, so that eliminates congruent. Okay, 8 and 12 are not congruent, but let's check and see, are they in proportion? Is 4 over 6 and 8 over 12 the same thing? So if I simplify it, divide that guy by 2, divide that by 2, divide this guy by 4, divide this guy by 4, that becomes 2/3. This becomes 2/3. Those match up. Yes, it's similar. They have the same scale factor, and that is the scale factor. Scale factor, if I'm going from 4 to 6, that means my scale factor has got to be bigger than 1, so that means it's not 2 over 3, it's going to be 3 over 2. That's my scale factor. So, similar, congruent, or neither, or similar, state the scale factor. So, 2.5 and 1.5 aren't equal. 3 is not equal to 1.7. 6, 2, 3, 4. So that eliminates congruent. So now I've got to look and play the matchup game. Is 2.5 over 3 equal to, I'm sorry, not 2.5 over 3, 2.5 over 1.5. Is that equal to 3 over 1.7? Is that equal to 6.2 over 3.4. And if you're not comfortable with that, we're doing it like doing some simplifying, then just throw in a calculator, that's fine. This becomes 1.667, 3 divided by 1.7. This becomes 1.7647. So those two are not equal, so that's going to be neither. Okay, so they're not similar, they're not congruent. They're just both cubes, or both prisms. So here, you've got radius and you've got slant height. You got to figure out, are they similar, congruent, neither? Well, 5 and 6 are different, so that eliminates congruent. So is 5 over 6 and 12 over 14.4 the same? Well, 5 over 6 is going to be 0.83 repeating. 12 divided by 14.4 is also 0.83 repeating. So those are going to be equal, so that's going to be similar. So, and then my scale factor is actually going to be 1 over 0.83 because I'm going from 5 to 6, so that's going to be 1.2. That's my scale factor right there. So cubes to the right are similar with a scale factor of 3 to 2. Find the surface, so they're cubes, so everything is 3. Or everything here is 2. So find the surface area of each figure, find the volume of each figure. So a cube, remember, is just going to be 6 one side squared. So 3 times 3 times 6 is going to be 54. 6 times 2 times 2, 6 times 4, it's going to be 24. And then volume, remember, is just going to be one side cubed. So that's going to be 3 cubed, and that's going to be 2 cubed. So that's going to be 8. I'm sorry, this is going to be 8. This is going to be 27. So I did that for a purpose because I want you to start comparing those two, because the original scale factor 3, 2, for surface area, if I simplified 54 over 24, I get 9 to 4th. Okay, so if I simplify it, I get 9 to 4. Here, 27 to 8, I can't simplify it, so 27 to 8. But notice something here. 3 squared is 9. 2 squared is 4. 3 cubed is 27. Let's draw it with a different color. 2 cubed is 8. Notice that. 3 to 2, 3 to 2 squared, 3 to 2 cubed. Take a look at that. So, here's kind of the basic idea. If two similar solids have a scale factor, then the surface area is that squared, volumes is that cubed. So, scale factor is for sides and lengths and heights. Surface area scale factor, square it, volume, cube it. Two similar cones of radii 10 to 15. What's the ratio of the surface area of the small cone to the large cone? Well, take a look. 10 to 15 is a scale factor. Surface area says if this is A, this is B, then my surface area scale factor is going to be A squared to B squared. So I don't even have to figure out like what the actual surface areas are, okay? I can, it takes longer, but all I have to do is realize that it's this squared to that squared. So that's 100 to 225, okay? And I can simplify that if I really want to. Two similar cones have radii 9 and 12. What's the ratio of the volume of the smaller cone? Volume, 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 and volume, 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 a larger cone. So 9 to 12, or if you really want to simplify it, 3 to 4. You know, divide both of these by 3, and you get 3 over 4. So for volume, remember, it's going to be A cubed to B cubed. So it's going to be 3 cubed to 4 cubed. So it's going to be 27 to 64. There's going to be the new ratio for that. Softballs below are similar spheres. The radius of the larger softball is 1.9. Find the radius of the smaller softball. So the bigger one, the radius is 1.9. Okay, so they give you volumes, and they're similar, so that means A cubed to B cubed. So that means this is going to be 9.15 pi is to 4.06 pi. Okay, so A, it's like A is 1.9. What's B? So you can always just take this and figure out what the radius is, and that'll help you with your comparison. Or you can realize that this is just going to be A cubed over B cubed. So 9.15 pi over 4.06 pi, cancel it out, and then ends up being just the cube root of that. So take 4.06, and in your calculator, if you raise it to the 1/3 power, that's taking the cube root. So it should be 1.5953 inches. 1.5953 inches. There's your answer. Okay, take a look at this. Ask a question if you need to. Take a look at some things and get ready for your test.